Hey, John here. Let's take a closer look at how Netnames are used in KiCad. What do they really mean? First of all, let's look at power pins. All right, so here's a simple schematic I just threw together. There's nothing else other than what you see right here. We've got ground and we got +5. I added the power flag so that we can go in here and do a DRC and not see any errors. Okay, now I have one symbol in here, and pin 1 is connected to +5 and pin 2 is connected to ground. So what does this really mean to KiCad? If we create a net list, now this is interesting because the net list is the only thing that flows from the KiCad schematic editor to the PC board editor. All right, so what we're going to talk about and look at here is the communication between your schematic and your PC board. How do things get named the way they are? What do they mean? That sort of stuff. All right. So the part that we care about in the net list, this thing defines the symbols and what footprints they all have and so on. But down at the bottom, there's a section called nets. So this is a list of every net in your schematic and what they're named. So here's a net named ground. And here are all the nodes, where a node is every pin, or what I like to think of as a terminal, a pin terminal that is connected to that net called ground. So you got JP1 pin 2, right? Well, that makes sense. Here's JP1 pin 2, and it goes to ground. There's nothing else connected to ground. It's the only thing in the schematic right now. Then there's another net called +5V that connects to JP1 pin 1, all right? Well, that's this over here, all right? So that means that this net here, the wire, the net that this wire represents, is called +5V, and this is the only node on it, which is that pin. This thingy up here that looks kind of like a fuse ball from the Atari Tempest game is kind of an interesting thing. If I was to click on this, I should have mentioned this in the other video. Notice what happened. This thing turned pink, and it turned pink over here as well. So what you've just done is you've just said, look, highlight all of the net that I'm clicking on. And that's the +5 net. Well, it makes sense. There's part of it here, here's part there. There's not a wire drawn between the two, but as I mentioned earlier, if you name a wire with a power pin or just type in a name on there, it becomes part of that net, whether it's visually connected or not. So if you connect the fuse ball over here, it'll undo it and click on a ground, and you can see these two guys light up, all right? So this is kind of a convenient way to look at what you know is going to propagate into the net list over here after you export it. So let's do a little more and look and see what happens as we add more parts to this schematic. So to do that, I'm going to just copy, let's just copy this part of the jumper here. Control-C, Control-V. Now I've got another jumper that's also connected to +5. Let's put a wire over here. Hit K. And let's put a regular old net name right on there like so. Let's call this one XX, all right? And save it. Let's look at what XX is connected to. It's not connected to anything else. All right, that makes sense because there's nothing else with an XX on it. If I was to then put a label over here on this ground net and call this one XX, what I'm doing is now ground has more than one name, okay? If now I click on the XX, you'll notice that this and this one over here are all now highlighted. All right, and if I create a net list and export it and save it, and I have to annotate it because I forgot I added that other part there. Let's look at this file. What happens now? I got ground has 2 pins on it, and +5 has 2 pins on it. Well, what happened to XX? Well, XX and ground are 2 different names for the same net. When that happens, KiCad is just going to pick one. All right, when it creates the net list, it has to call it something. I honestly don't know how it decides. I just assume it's random and don't worry about it, okay? So you can have more than one name for any net. And again, because the two wires have the same name, they are connected, all right? Now you can do more than just add an extra name on here onto, a net and give it two names. You can actually put more power connectors on the same thing, right? I'm on +5 right now. Well, what if I also want to have a VCC that's connected to +5, right? So this will actually be another way to add more than one name to a single net. So let me delete this out of here. Save it. Let's fuse ball this net here now. It has no name. All right. I didn't assign it one. It turns out, why don't we go ahead and export it real quick? You'll see that KiCad generates a name for you based on the part in the pin number that it's hooked up to. If we take a look at the new net list, you'll see there's a JP2 pad 1 net. Okay, and you've seen these when you edit your PC boards. If you don't name it, it gets a name like that. Well, that's where it comes from. KiCad names it itself based on the context of the thing, right? So what's my point? Well, if I now connect this guy up here to VCC, let's turn that off. Just click the fuse ball in the background here to undo it. And this one down here is connected to +5, and VCC and +5 are connected. Well, that means all of them are the same net. What's the name of this net? I honestly don't know. It's either going to be +5V or it's going to be VCC. Whatever KiCad does to decide what to name it is what it's going to do. So I'm going to export it again. We'll have one more look. And what did it call it? It called it +5V. All right? This is some evidence that maybe it uses the most original or oldest name. I don't know. It doesn't really matter. So, and this may not be the best design philosophy. This is really to prove a point, okay? Don't name your ground and then use that to propagate it to other nets. That's foolishness. It's only here to illustrate a point. So what else then can we do with these net names? What are the rules, really? Okay, when you name a net, you can pretty much call it anything. You can't put a slash in here, but it would be kind of foolish to start putting a bunch of special characters like asterisks and parentheses and square brackets and junk like this in here. It'll probably work as far as KiCad is concerned, but there are a lot of add-on tools and scripts that process things like the Netlist file, and if you fill it up with special characters, you might find that some, contributed open source things, if they're not tested well, these can wreak havoc. So just don't, I tend to try to name my nets based on the rules for like a variable in a C program. Technically, those are called identifiers. So if this is a C identifier, it would be only allowed to have upper and lowercase letters and numbers, then an underscore. Now, where KiCad is concerned, you also will make use of the tilde, right? Because the tilde puts a bar over something. So if you want to make it like a negative thing with a bar over it, you put a tilde in there like that. Now, these two nets are different nets now, right? Because they don't have the same name anymore, all right? So, again, let's not get too creative with our names. Otherwise, who knows what will happen. So one last point before we move on to the next subject. I just made this a new name. Let me export a net list and look at it over here. You see how this is a slash in front of it? This one does not. This one does not. If you're looking and poking around in your Netlist file, any net that has a slash at the beginning of its name is a local net. And if it does not have a slash in front of its name, it's a global net. So what is the difference between the two? It's not relevant if you have only a single sheet, but if you have two sheets, the only net name that's available in both sheets and means the same thing in both sheets would be a global net name. Since this is a local net name, it could easily be that a final schematic with multiple sheets could have an XX bar in each of the two sheets, but if they're both local, they're different XX bar networks, okay? We'll see more about that when we get to multiple sheets. Now let's have a look-see at a bus, right? So let's look at the rest of the stuff over on the right side of the page here, right? So we just talked about the fuse ball, you know about the symbols and the power ports, and you know how to place a wire. This blue thing is a bus, which is really just a plurality of wires. Let's just draw one on here, right? You draw it just like you would a wire, all right? I just started here, went over there, hit, clicked it, and hit K to end it. These are called wire to bus entry. These actually don't do anything at all, but they provide a visual clue to a browser or a schematic. These also don't do anything on their own other than provide a visual clue. We already know about the no connect, all right? And you know about the placing of a junction. This happens by default when you connect two wires like this. I'll hit a K there. That's a junction right there. You can also have a junction between two buses, like this. If I click the darn thing and come around here and hit K, now these two buses are connected at that junction, okay? Now, what in the world is going on with these buses? How do they work? Well, what happens with a bus is when you put a net name on a bus, what you're doing is you're creating a plurality of nets all at the same time, and it's an enumerated set. So let's say we create a net called A0, well, let's call this 1 through 4, okay? This says I have a set of 4 wires in here, and it's A1, A2, A3, A4, okay? Now, I have a part over here. Let's put a connector. What is this thing? A generic 1x4. There we go. Let's make some room here. Let's put one of them over here. All right. And let's say these 4 pins, we're going to put some wires on here. Over here and hit K. Now, by the way, here's a handy thing. I've just drawn a wire right there, right? If I hit insert, it's going to draw another one the same length, 1/10 of an inch below it. And it's going to keep on going. So I just drew one and hit insert 4 times to do that, all right? So let's move this over so I can get a close-up of all this at once. There we go. Now let's put a net name on here. Now, I'm going to call this net A1, mostly because it's on pin 1. Click that. Hit escape. And again, hit insert 1, 2, 3 times. Well, it'll do the same thing with the net name, and if it ends in a number, it adds 1 as it goes. So this is a really convenient way to create a whole lot of these all at once, all right? So what does this really mean? I have 4 wires named A1, 2, 3, 4, and I have a bus called A1 through 4. These 4 wires are part of this bus. And the only reason that's true is because they are named using a convention that maps them together. Now, normally in schematics, you would see something that looks like this. Hit K to end that. Then you put a wire to bus entry over here. What am I clicking on the wrong thing there? Here's a wire to bus entry. And, of course, I missed. Move it up like this. Let's put another one down there. And now I can hit insert to do the rest, save. Normally this is what is going on in a lot of schematics you see all over the place. This is very much conventional how you present this. This says this is A1 through 4 from this bus that is collectively known as A1.4. Okay? If we create a net list right now and have a look-see in here, I'm going to annotate the connector, okay? Now you got A1, 2, 3, and 4, and they all start with a slash. So these are local net names. The net has 1 node each because it's the only thing connected to these nets, right? If I put a second connector, let's just copy this whole thing right here. Control C, Control V down here, save. And I can look at it with a fuse ball. If I click on A1, what happens? Well, this is a member of what net? The A1 up here, it's also part of the bus. If we look at the whole schematic, we don't see anything down here. So That is the sole extent to which this net runs through the schematic. If we click on A2, we click on A3, click on A4, all right? If you click on the bus, it won't do anything on its own, all right? Because this is more than one net, all right? So the fuse ball thing doesn't really work if you click it on a bus as a whole, all right? So you can easily see where these things are going. All right, now, because these guys, let me turn that off here. Because these angle thingies are just for ornamentation, if you delete them, it still works, right? You know, even if you delete this entire bus over here, it'll still work. Because these are two nets in the same sheet that have the same name, okay? So you might ask, what's the point of having a bus? Well, this is where it gets interesting. If you start playing games with, you know, giving multiple names to a bus, you have the same situation that happens when you give multiple names to a net. So if we call this one A1 to 4, all right, save it. Whether I wire it and visually connect it or not, this is a bus that represents all the pins over here, all the nets, rather, you see over here, okay? Now, if I was to give this an alias, copy, paste, I can connect it to another bus. So let's create another connector here. Call this B1. And insert, save. Okay, fuse ball me. All right, 4s are connected, but B4 is not. Of course not, because it's not A4, right? A1 and so on. But if I put another net name over here, or bus name rather, now I'm saying that A1 through 4 and B1 through 4 are the same bus. And I grab a fuse ball and I hit A1, you'll notice all these guys come together here. All right? Now I could make this work also without a bus, okay? I could easily create 4 separate wires over here, and on each one of those wires put an A1 and a B1. And then the second wire I could put a B2 and an A2. Third wire I can B3 and A3, and a fourth wire I can say B4, A4. That would be the same thing as what I did here with the bus. Now, imagine a bus that has 64 pins on it, or 64 nets, I should say, in it. You don't want to have to do that out 64 times. This just does it in one mass, all right? I'll make sure that we really understand what's going on here. Let's have a look-see at what happens if this becomes something else. Come on. All together. Let's put a C over there. C1. Insert, save. Okay, now hit escape, check the fuse ball. Of course, I didn't do anything with this thing yet, all right? So let's see what happens if now I put an alias C1 to 2 on here. Now what's going to happen? Well, give me a fuse ball, clear it. Now, if I hit C1, it connects to A1 and B1. If I connect to C2, that all makes sense. When I get to C3, because it's not part of the bus that is alias to these other guys, this does not connect to the other nets, okay? So you can use this to selectively alias ranges of pins. Now, the other thing you need to know about this is that the enumeration range 1 through 4 and 1 through 2, you can't do some. I mean, if you said 2 through 3 on here, you'll notice that the ones that are connected are based on these numbers in the brackets, right? So C1 is not connected to anything. C2 is. C3 is. And C4 is not. All right? So you cannot use this to connect like C2 to A1 and so on, right? If you really wanted to connect C2 to A1, you'd have to come over here and do it on a wire like this, okay? Let's just do it for the sake of illustration here. C2 and A1, oops, A1, all right? If you do that, and you click, whoa, I don't want to do that. I want to fuse ball me. Here we go. Now I got C2 is connected to A1. Now C2 is also connected to A2 through this bus aliasing up here. So by clicking this, I got A1 and A2 and C2. All right. Now this is really confusing. This is terrible. Don't do this in a real schematic. All right. This is all just to prove a point, illustrate a point that this is how this aliasing mechanism works. And you can do it with a bus. You can do it with a single wire and some net names. All right. All right. So one last thing here. When it comes to buses, if you're going to draw them like this, you have to be careful. All right. Remember, just like these green jobbies, the wire to bus entry, the bus to bus entry literally don't do anything. They just provide a visual tool that you can use in your schematic. When I have a bus wire here that connects with a junction to the bus up here, then these really are the same bus, right? So if I connect to C1 right now, I have no connectivity. Remember, I deleted that net right there. C2 connects to A2 and B2. Why? Because of this in here, right? Now, if we turn this off for a minute, come back here, go on to this, and I delete this part of the bus, save, then I'm back to isolating the C bus from anybody else because this is not connected, right? There's nothing going on between here and bus C. And if you were to put one of these on here and connect this bus, see, that looks weird. Go the other way. Move. Okay. Now, I've seen this done in some schematics. All right. These two buses are not connected together. So if you fuse ball your way through the C's here, notice how this is lit up. It doesn't go through this angled piece, all right? You probably don't want to use this, all right? You're going to confuse yourself and anybody looking at the schematic here. Because if you do this, this is very confusing, all right? Delete that. If you want to connect them with a junction. All right, now you can trick your friends. There's a bar bet waiting to happen there. Are these the same or not? All right, those now are connected. All right, again, to drive home a point, make sure that you understand when these things are connected, what becomes an alias of what. All right, so go forth and label your nets and your buses and your schematics. Thanks for watching. Let me know what you think in the comments. If I overlooked something or I'm wrong about something, definitely let me know. Thanks a lot. We'll talk to you later. Bye.